Hey guys, this is Unit 3, Concept 3, Ions and Isotopes. We are going to start with ions. Ions are atoms that have gained or lost electrons. Okay? Now, since electrons have a negative charge, that's going to change the charge of the atom. Okay? So it's no longer going to be neutral. So ion formulas will have a charge and they are written with a positive or negative superscripts. Okay? Alright, there are two types of ions. Okay? We can have a cation, C-A-T-I-O-N. Alright? Cations have lost electrons. Okay, so since they have lost electrons, they have more protons than electrons, and since they have more protons, they're going to be positive. Alright, and the second type of ions are the anions. Anions have gained electrons. Okay, gaining electrons means they get more electrons than protons, so they will have a negative charge. Okay, so an easy way to remember this is the cat. Okay, this looks like a positive sign, so cations are positive. Okay, and the an, if you remember this, it has an N in it, so anions are negative. Now, how do you figure out the number of electrons in an ion? You take the atomic number. Okay, take the atomic number, and we're going to subtract the charge. And that will equal to the number of electrons. Okay, so let's look at the examples here. All right. I'm going to look at the big periodic table that is in our class. You need to go and get your periodic table. Alright, so Mg plus 2. What you're going to do is look for Mg on your periodic table. It is atomic number 12. Okay, the mass number, its atomic mass is 24.305, so it's going to round to 24. The number of protons is still the same as before. It is 12. Okay, the number of neutrons, same as before, 24 minus 12, and that will give us 12. Okay, now the number of electrons is what's going to change. We are going to take the atomic number, which is 12, and subtract the charge. The charge is positive 2. Okay, 12 minus 2 is 10, so we have 10 electrons. S minus 2 has a atomic number of 16. The mass number is 32. Okay, 32. The number of protons is the same as the atomic number, so it's 16. The number of neutrons is 32 minus 16 equals 16. Okay, so far everything is the same as what you knew before. Okay, now in the electrons, remember electrons are the things that are different in ions. Okay, so we are going to take the atomic number 16 and we're going to subtract the charge. In this case, it's a negative 2. Okay, 16 minus a negative 2 is the same as 16 plus 2, so that is 18. Alright, Br minus 1. Br has an atomic number of 35. And its atomic mass is 79.9, so we are going to round it up to 80. Okay? And the number of protons is 35. We are going to take 80, subtract 35 for the number of neutrons, and we are going to get 45. Alright, the number of electrons. Take the atomic number, 35, subtract the charge, negative 1. 35 minus negative 1 is 36. Li plus 1. Li has an atomic number of 3. its mass number is 6.9, which rounds up to 7. Number of protons is 3. Number of neutrons, 7 minus 3, we get 4. Okay, the number of electrons. We take the 3 from the atomic number and subtract the charge. The charge is positive 1, so 3 minus 1, which is 2. Alright, atoms and ions of the same element have different numbers of electrons, but the number of protons is always the same. Okay, you should know that the proton is what defines the element. So if it changes, if the number of protons changes, then it changes the entire element. Okay, atoms and ions are still the same element. The only difference is their electrons are different. Okay? Okay, isotopes. Isotopes are atoms of the same element with varying numbers of neutrons. Okay, so their neutron numbers are different. Alright, now since their neutron numbers are different, that's not going to change the charge, but it's going to change the mass. Alright, so that's going to change our mass number. So for example, carbon has 2 common isotopes. Carbon 12, C12, this 12 is the mass. Okay? Alright, so when we write it as C12, the 12 is the mass. So what this is telling you is the proton number is still the same as regular carbon. Electron numbers are still the same as regular carbon, but neutron numbers are going to depend on the mass. Okay, so we are going to take 12 minus the atomic number to get the neutron number. Okay, the proton number for carbon is the atomic number, which is 6. Okay, which means the number of electrons is also 6. Alright, the neutron number, you're going to take the mass, which is 12, and subtract the atomic number, which is 6. 12 minus 6 gives you 6. Okay, now another common isotope of carbon is carbon 14, or C14. Alright, so that means the mass this time is 14. So the proton number doesn't change, it's still 6, because the atomic number of carbon is 6. Okay, the electron number is still 6, but the number of neutrons has changed. So it's 14 minus 6, which is 8. So notice the only thing that changes in isotopes are the neutrons, not the protons and not the electrons. Okay? Now we also have an isotope symbol. Okay? Isotopes are written like this, where this is the mass, okay, and that is the atomic number. Alright, so in the case of carbon 14, it'll be C with the 14 on the top and 6 on the bottom. 14 is the mass and 6 is the atomic number. Okay? Alright, so let's look at these examples here. Hydrogen 3, that means the mass is 3. Okay? The atomic number of hydrogen is 1. Notice that we are going to now ignore the atomic mass because right here the given tells you that the mass number is 3. Okay? The number of protons is 1 and the number of electrons is also 1. Now we look at the number of neutrons. Okay? We are going to take the mass number, which is 3, subtract 1, and we get 2. Alright, copper 65. That means the mass number is 65. The atomic number of copper is Cu. Okay? Cu is atomic number 29. The number of protons, therefore, is 29, and the number of electrons is also 29. Alright, the number of neutrons. We are going to take 65 and subtract 29. And we will get 36. Okay? Uranium-239, uranium is U. Okay, uranium is atomic number 92, and the mass number is 239. That is given to us. We don't have to look it up. Okay, the number of protons is 92, and the number of electrons is 92. All right, let's figure out the number of neutrons. It's 239, subtract 92, which is going to give us 147. We have 3 isotopes of hydrogen. Hydrogen 1 is called protium. Okay, remember that the 1 after the dash means that that is the mass number. Okay, so this is H, mass of 1, atomic number 1. Okay, the proton number is 1, the number of neutrons is 0, and the number of electrons is 1. Okay, hydrogen 2 is called deuterium. Okay, and here's its symbol. The proton number of deuterium is 1, the number of neutrons is 1, and the number of electrons is 1. And hydrogen 3 is called tritium. Okay, and here's its symbol. Alright, the number of protons is 1, the number of neutrons is 2, and the number of electrons is 1. So those are the isotopes of hydrogen. They have special names, so make sure you know the names. The atomic mass on the periodic table is actually an average of the mass number of all of the isotopes of an element weighted by the percentage of abundance. Okay, so what does this all mean? This means that the atomic number that is on the periodic table is actually not the real mass of the element. Okay, the atomic mass on the periodic table is actually an average of all of the mass numbers that we found of the isotopes. Okay, so you should know by now that the isotopes of an element have different masses. Okay, so for example, with carbon-12 and carbon-14, we have some carbon element or carbon atoms that have a mass of 12 and some carbon atoms that have a mass of 14. Okay, and what scientists have done is they took all the carbon that they found and figured out how much, what percent is 12 and what percent is 14, and make that into an average weighted by the percent. Okay? Now how they did this is by using this formula. The average atomic mass is equal to the percent times the mass number of the first element or the first isotope, okay, plus the percent times the mass of the second isotope plus the percent times the mass of the third isotope, and so on and so forth. Okay, so if we have 5 different isotopes, then we will do this 5 times and add them all together. Okay, so let's look at some examples here. Copper exists as 2 isotopes. We got Cu63 at a 69.17% abundance and Cu65 at a 30.83% abundance. Find the average atomic mass. Alright, so what we are going to do is change the percentages into a decimal first. Okay, and you should know this from math class. You just take the decimal and move it 2 places to the left, and that will give you 0.6917. Okay, so 69.17% is 0.6917. Alright, and then we're going to do the same thing with 30.83%. Okay, move the decimal 2 places to the left, and you're going to get 0.3083. Alright, now let's figure out where the masses are. The masses are 63 and 65. So now we have all the information that we need to calculate the average atomic mass. We are going to take the percent of the first one, 0.6917, and multiply by the mass, 63. And we're going to add this to the second one. Okay, the percent, 0.3083, times the mass, which is 65. Okay, and you're going to punch this into your calculator. Go ahead and do that. And you should get 63.62, and the unit is U, or AMU, okay? Alright, so that is the average atomic mass of copper based on this information. Let's look at the second example. What is the average atomic mass of lithium if 7.42% exists as lithium-6 with a 6.015 U mass, and 92.58% exists as lithium-7 with a mass of 7.016 U. So this one is more specific with the masses, okay? Alright, the first thing that we're going to do again is to take the decimal from the percentages and change them into an actual number. So this will be 0.0742, okay? And the 92.58% is going to become 0.9258. Okay, and now we have all the information. The first percentage is 0.0742, and we're going to multiply it by the first mass, which is 6.015 U. Okay, plus the second percentage is 0.9258, and we're going to multiply by our second mass, which is 7.016 U. Okay, go ahead and punch that into your calculator, and you should get 6.942 U.